Hello my dear friends, welcome to my YouTube channel. Myself Dattu Patel from LJ Institute of Engineering and Technology. Last lecture we are already discussed about the infinite series, telescopic series and geometric series. Today's session we are going to discuss about the test of divergence and Cauchy's integral test. Let's see firstly the basics theorem. If the series summation n equal 1 to infinite un is convergent, then limit n tends to infinite un equal to 0. But the converse of above theorem is not true. That means if limit n tends to infinite un equal to 0, then summation n equal to 1 to infinite un not be convergent. Now let's see the test for divergence, or we can say that zero test. If limit n tends to infinite un not equal to 0, then the summation un is divergence. Now let's see the one example which is based on zero test or test for divergence. So that the series summation n equal to 1 to infinite n square upon 5n square plus 4 is diverges. Here un equal to n square upon 5n square plus 4. Now applying the limit n tends to infinite to the un, then limit n tends to infinite n square upon 5n square plus 4. Here n square which is common in numerator and denominator portion, then it becomes limit n tends to infinite 1 upon 5 plus 4 by n square. Now n is a infinite, then 1 upon 5 plus 0, that means it is 1 upon 5 which is not equal to 0. So the series is divergence. Now let's see the one more example. Is the series 1 plus 4 plus 7 plus 10 and so on is convergent. Here our series which is in form of arithmetic series, then we have to find the n terms of the series. Then with the help of formula a plus n minus 1 into d. Now here a indicated by the first term of the series which is 1, and d which is difference between two successive terms, means difference between 4 and 1, that is 3. Now substituting value of a and d in this equation, then our un becomes 3n minus 2. Now here with the help of partial sum, Sn, that is the sum of the first n term of this series, which is u1 plus u2 plus u3 and so on up to un. Now substituting the n equal to 1, 2, 3, 4, 5 and so on up to n, then it becomes 1 plus 4 plus 7 plus and so plus 3n minus 1. Here this is the arithmetic summation of the partial sum. Then it's become, we have the formula n by 2 inside the bracket 2a plus n minus 1 into d. Substituting the values of a and d and simplified it, then it becomes n by 2 inside the bracket 3n minus 1. Now applying the limit n tends to infinite Sn, then it becomes infinite. Therefore given series is divergent. Here we use the partial sum method. We can also solve the with the help of divergence theorem or a zero test. Then here applying the limit n tends to infinite to the un, then it becomes infinite. Then according to the divergence theorem or test for divergence, it is divergent. Now let's see that. Check out the one more examples. Discuss the convergence 1 minus 1 plus 1 minus 1 and so on. Here we have this series, first one which is positive, second one negative, third one also positive, negative and so on. Then we can say that given series is alternating series. Now finding the n term of this series, then un equal to minus 1 raised to n plus 1 or minus 1 raised to n minus 1. Then with the help of partial sum, s1 equal to u1, that is 1, s2 equal to u1 plus u2, that is 1 minus 1 means 0, s3 equal to u1 plus u2 plus u3 means that is 1 minus 1 plus 1, it becomes 1 and so on. Then in general form we can say that whenever our term has a even term, means 2, 4, 6, 8 and so on, then we get the 0. And whenever our term means s1, s3, s5, s7 and so on, then it becomes 1. Means our limit has more than one value, means it has more than one value which is 0 and 1. Then we can say that given series is oscillatory or limit does not exist, therefore it is divergent. Oscillatory series, that is a particular form of the divergence. Now let's see the next topic, which is positive term series. An infinite series in which all terms after some particular term are positive, then the series are called the positive term series. Let's see the one example. Suppose we have the series 1 plus 2 plus 3 plus 4 plus 5 and so on. Means each and every terms of this series which is positive, then we can say that it is positive term series. Here we see the one more example. Minus 7, minus 5, minus 1, plus 5, plus 13, plus 23 and so on. Means in this series first three terms are negative. Then after, means after some particular term, remaining all the terms means 1, 5, 13, 23 and so on. These all are the positive. Means we can say that it is positive term series. Now let's see the one more topic of this lecture, which is Cauchy's integral test. Here f be a continuous positive decreasing function on interval 1 to infinite and un equal to f of n, then the series summation n equal 1 to infinite un converges or diverges according to the improper integral. Integral 1 to infinite f of x dx is finite or infinite? In short, our integral 1 to infinite f of x dx is finite, then given series is convergent, and integral which is infinite, then we can say that given series is divergence. Now let's see the check out the one example based on Cauchy integral test. Check the whether the series summation n equal to 1 to infinite 1 upon n square plus 1 is convergence or divergence. Here un equal to 1 upon n square plus 1, that is our f of n. Now replacing n as a x, then f of x equal to 1 upon x square plus 1, that is our continuous function and positive decreasing on interval 1 to infinite. Then with the help of integral test, applying the limit interval 1 to infinite, here we have the range of summation which is 1 to infinite, then our integral range which is 1 to infinite. Suppose we have the summation range which is 2 to infinite, then our integral range becomes 2 to infinite. Suppose 5 to infinite, then our integral range which is 5 to infinite. Then here integral of 1 to infinite 1 upon x square plus 1 dx. Then with the help of improper integral, means we have upper limit infinite, then it is replaced as a constant term b, and applying the limit b tends to infinite. Then here limit b tends to infinite, integral 1 to b 1 upon x square plus 1 dx. Now we know that the integral of 1 upon x square plus 1 which is tan inverse x. Now applying the upper limit minus lower limit, then it becomes limit b tends to infinite, tan inverse b minus tan inverse 1. Now applying the b as a infinite, then it becomes tan inverse infinite minus tan inverse 1. Now you all are aware about the value of tan inverse infinite and value of tan inverse 1, then which is pi by 2 and pi by 4. Now subtraction of that value, then it's pi by 2 which is finite, means our integral is finite. Then according to the Cauchy integral test, we can say that given series is convergent. Now let's see the one more example of the test of convergence of this series summation n equal to 2 to infinite 1 upon n log n. Here un equal to 1 upon n log n, that is our function f of n. Now n, replace n as a x, then f of x equal to 1 upon x log x. Here what obvious, f of x is a continuous and decreasing on interval 2 to infinite. Then with the help of integral test, here in range of integral which is 2 to infinite, because we have the summation range which is 2 to infinite, then 2 to integral range which is 2 to infinite 1 upon x log x dx. Now with the help of basic simplification and improper integral, it becomes limit n tends to infinite integral 2 to m 1 upon x upon log x dx. We have already formula integral f dash of x upon f of x dx equal to log of mod of f of x, which is already learned in 12th science. Now applying this formula, then we get limit m tends to infinite log of x Now applying the upper limit minus lower limit, then it becomes limit m tends to infinite log of m minus log of 2. Here m as a infinite, then first term which is infinite and log 2 which is finite, means infinite minus some finite value which is tends to infinite. Then according to the Cauchy integral test, our answer which is tends to infinite, then we can say that given series sigma un is divergent. Now let's see the one more example. Test the convergence of this series summation n equal to 1 to infinite 2 tan inverse n upon 1 plus n square. Here un equal to 2 tan inverse n upon 1 plus n square, that is our f of n. F of n is a continuous and positive decreasing on 1 to infinite, which is our interval. Now applying the integral test, which is 1 to infinite 2 tan inverse x upon 1 plus x square dx. Here applying the improper integral concept, the limit m tends to infinite integral 1 to m 2 tan inverse x upon 1 plus x square dx. Here we have the integral formula, integral f of x into f dash of x dx. Also we use the substitution method. Here I am taken the substitution method, means tan inverse x equal to t, which is assumed. Now derivative of that term means 1 upon 1 plus x square dx equal to dt. Now here we have the range of x which is 1 to m. Now apply when x equal to 1, then t becomes pi by 4, and when x equal to m, then t becomes tan inverse m. Now this all the things we put in this equation, and our integral becomes integral 1 to infinite f of x dx equal to limit m tends to infinite pi by 4 to tan inverse m to t dt. Now integral of 2t, that is 2t square by 2, which is 2 to cancel out. Now applying the upper limit minus lower limit, then limit m tends to infinite tan inverse m whole square minus pi square by 16. Now applying the m as a infinite, then tan inverse infinite whole square minus pi square by 16. You all are aware about the value of tan inverse infinite, which is pi by 2. Now it's pi by 2 whole square, means pi square by 4 minus pi square by 16. Now simplify this term, then it becomes 3 pi square by 16, which is finite. Then according to the Cauchy integral test, our integral which is finite, then we can say that given series is convergent. Now let's see that, check out the one more example. This example which is based on our first basic theorem, the limit n tends to infinite 1 upon n equal to 0, but the series summation n equal to 0 summation n equal to 1 to infinite 1 upon n is divergent. Our basic theorem is if the series sigma n equal to 1 to infinite un is convergent, then limit n tends to infinite un equal to 0. But convergence was not true. Here un equal to 1 upon n, which is our f of n. Then replace n as a x, then f of x equal to 1 upon x. Now apply the Cauchy integral test, that integral 1 to infinite 1 upon x dx. Now with the help of improper integral, limit m tends to infinite integral 1 to m 1 upon x dx. Now applying the integral, then integral of 1 upon x, that is log x, then upper limit minus lower limit, then it becomes log m minus log n. Now m as a infinite, then it becomes tends to infinite, means our answer which is integral which is tends to infinite, then we can say that our series is divergence. These all are the about the topics integral test and divergent test, or we can say that zero test. I hope you guys learn something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do this, share with them. If you want to watch more tutorials, more videos like this, then you can subscribe my YouTube channel. Means whenever I upload the new video, you get the notification. If you have any query regarding this topic, then feel free contact me. Thank you so much for watching me.